Okay, so for 5.4, we have what's called special situation solutions, and basically that means that three things could happen when you are, for example, graphing, and then I'll show you what substitution and elimination looks like. But for example, the first kind that we have are the two lines could cross. So for example, if you have a coordinate plane and you have a line that does this and a line that does something like that, it crosses at this one place right there. So that's what we have been doing the first three sections. We've just been getting one answer. We have an answer like -2, 2. That's a one solution. That's what we have been doing. Now, sometimes when you graph a line, you could get parallel lines. Okay, so what happens is if we have this line and we have this line, they never ever cross. So if they never ever cross, we can't write a solution, because remember, the solution is where they cross. So if they never cross, we write no solution. And again, I'll show you what the equations look like for no solution. And then sometimes when you graph, you'll be going to graph a line, and you'll graph the first one, and maybe it's this point, and this point, and draw yourself your line. And then you go graph the second line, and they're all the exact same lines, and the lines land directly on top of each other. So really that means you're graphing the exact same line twice, which some people are like, well, why would you ever graph it twice? Well, sometimes you don't realize it's the same, and then it turns out to be the same. So if it's the exact same, you can see how like this green dot goes right over the red, right over the red, right over the red. The whole line is right over top of each other. Well, then that means there's going to be infinitely many solutions. So those are the three types. This first one's not really special. That's what we have been doing the first three sections. It's these last two that are kind of the special situations. Okay, so what if you don't have a graph, and maybe you don't want a graph? What happens for a no solution or an infinitely many solution? So first of all, if it's a one solution again, it's just going to look like the same answers that you've gotten for the first three sections. So you're not going to know if it's a special kind. You're going to solve like normal. So if I saw this one, I would probably solve it using substitution. I would probably substitute this in for y. So 2x plus 2 squeezed with the box equals 4. Distribute 2x plus a -2x plus 6 equals 4. Combine your x's. Well, 2x minus 2x is gone, so all you have left is 6 equal 4. Well, if you remember back to chapter 1, whenever we had an equation that ended like that, you had to actually answer if this was true. Does 6 equal 4? Well, never. 6 never equals 4. So if you end up with a false statement, this means no solution, because it's false. So if it's false, it means no answer. So no solution leads back to our graph of parallel. So these must be parallel lines, something like this, because they're never ever going to cross, because it says no solution, because you got something that looks like this. So whether you see the graph or whether you solve it, you should be able to figure out which kind of answer it is, if it's a one solution, an infinitely many, or a no solution. Okay, so I'm going to do an infinitely many example. So again, maybe you don't want a graph. Maybe you see something like this, and you think this would be perfect for elimination. So that's totally fine. You can use the elimination. And if I'm going to eliminate here, or actually you could even use substitution pretty easy on this top one, but I'm going to show you elimination just to show you another method. So I'm going to notice that this whole top equation, I'm going to multiply it times 3 so I can get my x's to disappear. So this becomes a 3, this becomes a 9, and this becomes an 18. Because all I did was I multiplied every single number times 3. Okay, so now if I'm going to use elimination, it looks like if I want to make these disappear, it looks like I'm going to have to minus. So 3x minus 3x is gone. 9 minus negative 9 minus a negative 9, ugh, that's also gone. So now I have both of them disappearing. So what do I have left on this side? 0. So, well, I got to keep going. 18 minus 18. Oh, well, that's also 0. So does 0 equal 0? Yep, all the time. This is true. 0 does equal 0. So anytime you get a true statement, that's going to be infinitely many. So if I actually graphed those two lines, they would be the exact same line. I would go to graph the first one, might look something, let's see, might look something like this, and then I go to graph the second one, and it's right over top, well, that wasn't right over top, but right over top of the other one. So it means every single dot is going to land on every other dot.